Hello and welcome to Technically Speaking, the podcast where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura, and in this episode I'm joined by Rwayda to talk about tall buildings. But Rwayda, you're a civil engineer and I'm a scientist who's fairly ignorant about this sort of thing. So how are civil engineers able to build something like a skyscraper and be confident that it won't fall down?
Well, it started when the steel industry moved into the future, and that was around the early 20th century. So the material for building such a building was provided, also the science. So the main two things you need for building a tall building, you need a good foundation for the building to stand on, and you need a good material. So the industrial revolution with the steel was half, and the other half is the knowledge about the soil and how you deal with it. So getting a better foundation, because they try to base it on bedrock layers so it would be stable and don't sink in the soil.
So that's basically like, digging down through all the soft stuff, the soil that you mentioned, and finding something solid to build on, right?
Yes, precisely.
I guess there are places where you can't find the bedrock to build on, but people do it anyway.
Well, that's interesting because the tallest building standing now is Burj Khalifa, and it's built on the sand. And they really used some sort of foundation called pile foundation, which means you dig into the ground, into the soil with a pipe. It's like digging in a tube, then filling that with concrete to provide a friction between the soil and the concrete, and the friction would hold the weight. So it's not only one pile, it's 100 of them. And all these piles are reinforced with steel as well. So it's kind of like it holds its own weight and some of the load on it. And then the main mechanism of transferring the weight of the building, similar to the rock. So the rock would take the whole load, but now the friction between the soil and the pile will take the load.
Okay, so if I'm being really scientific about this, and you're talking about friction, this might be a really stupid question, but does someone calculate how long a pile you need to have to get enough friction?
Yes.
So
you need to calculate how long, how many, what the distance between them, because you're creating a whole, you kind of like creating your own rock bed layer. You don't want to disturb the soil. You want to space them out, and you want the pile to be in a appropriate diameter. Also, you want the length, because you don't want to dig too deep, then hit the water, because you have the water saturation happening, and if you hit that, that's not a good thing. And also you need to treat the soil and lower the water elevation so that won't cause a problem in the soil. So it's quite a complicated process.
Wow.
We need a geotechnical engineer to explain it.
I was going to say we could probably do a whole episode on just talking about the foundations, but that's not really why we're here.
Yeah.
From what you're saying, I guess the foundations are kind of the size of the scales with the height of the building. So a taller building needs deeper foundations. Is that right?
I would put it like a stronger foundation.
Okay.
Because deeper sometimes won't mean stronger if you start digging the rock bed underneath. So you want it to be till then, and you find this layer that you will use it to anchor your load or do the piles.
Okay.
And sometimes if you dig too deep, you might go into problems. So the stronger your foundation is, the taller you can build.
Okay, so it's not necessarily about just digging deeper. Gotcha. You mentioned the Burj Khalifa, which is in Dubai, and that is a flipping tall building.
Yes, it is. It's the tallest building now.
Yeah, there isn't really a definition of what makes a skyscraper, right? There isn't anything that if it's over this tall, then it's a skyscraper.
The definition of how tall the building is to be the tallest or the skyscraper is changed through history because the change of what we're seeing in the materials. So historically, it was between 10 and 20 stories. Now it's between 40 and 50 stories. It's just ridiculously changed because we have more technology to build things now.
Yeah, that makes sense. So historically, you're saying sort of 10 or 20 stories. That's probably what, 100 meters at the most?
Yes.
Rather than the hundreds of meters that you see in some cities.
Yes, Burj Khalifa is about 800 something meters high. Also, we should mention something else that just jumped in the top of my head now is the invention of lifts or elevators. really helped with tall buildings.
I guess so. I guess you'd be really, really fit if you didn't have one, though.
Well, imagine going up like 50-story. Well, I barely can do 3.
I spend a lot of time, or did spend a lot of time, hill walking anyway. So I was climbing mountains that were, well, nearly a kilometre tall, but not just going straight up constantly like you would on a staircase, I suppose. It's a bit different.
That's quite a hike.
Yeah, and it took a while. So yeah, maybe you're right. Maybe the lifts have made a big difference, or elevators made a big difference to how tall you can go. So once you've sunk your piles, or you've dug into the bedrock, or do you dig into bedrock, or do you just sort of pin the things to the bedrock?
You dig in to near them and anchor your either pile again, or if you don't dig through them, or do a bed foundation, which basically you cast a cube of concrete and it would settle on them.
Okay, so then once you've done that, you can start building up. So what does that construction? I see on TV things like steel frames and girders and stuff, but tell me more about it.
You start with steel frame. That's why I said steel industry helped a lot building vertically. So you start with the steel frames, which when they started building with them looked like a cage. Then you use concrete. So you use steel and concrete usually. So the concrete also provides stronger external layer, and you put it in the main areas, and then you will build up. Once you secure your foundation, you build up.
Yeah. Is there any particular consideration of like the shape of that steel frame, or how many different cross pieces you have to put in? I'm guessing you can't just do whatever you want. There must be physical principles.
No, you need to do the calculation as you said, but it's not very restricted. But sometimes when you build in a certain way, you would avoid certain external impacts. So let's say the wind or something. So when you build something circular, it's react better to the wind.
Yeah, because having been on top of those mountains, it is pretty windy up there, even if it's not windy lower down.
Oh, interesting.
So yeah, there have definitely been times where like it's a sudden gust, you have to I have to stop and plant my feet and just wait for it to pass, because I'll get blown off the mountain otherwise.
Oh yeah. So what you experience is something that is a problem for the tall buildings. This wind would cause them to sway. Interestingly, earthquakes would have quite a similar effect, because it would just excite the base of the building, get it to sway. And there's like a few methods to protect the building from swaying. So you have something called external tubular frame. So you would get your external frame of the building, rather than the cage I was talking about, be stronger to protect the building. The other thing is using number system, and also what I was talking about a circular some sort of building. So if you think of Burj Khalifa, it have what they call a leaf foundation, and you can even link it to a plain wing. It have this smooth radius that the wind flow through, and it won't kind of impact it. So it would slide by it rather than push it.
Oh, I see. So I've seen some buildings that have got chimneys on them, but the chimney's got a sort of a corkscrew around it. Is that to direct the wind around it? So I guess in that case, the wind will either curve up or down.
Exactly. So kind of you deceiving the wind. I think it's a strange example here. It's similar when you jump to the water and have your hands in to break the water first, so you don't hit your head with the water tension and everything and get a headache or break your neck. So it's kind of the same idea when you break the wind as a medium with this like kind of wingy, leafy shape of the edges.
I'm gonna have to go look up some pictures now, because a leafy wingy building sounds quite interesting.
Well, if you just Google Burj Khalifa and how they build it, it have like 3 leaves that the wind would break on the edges, and it is not a problem anymore.
Cool, I will definitely do that. And you mentioned other methods. You mentioned tubular frames and dampeners, and you also mentioned earthquake. So do they use the same design principles in buildings in earthquake zones?
Yes, they do. Both earthquake and wind would cause the building to oscillate. And one of the systems is called the tune mass system. If you think of a pendulum, you will have the pendulum on the top of the building. So once the building is sway one way, the ball will go on the other side and get you to balance. One of the example is the Taipei 101 building in Taiwan. and it has that system of a ball that balances the building on the top, and it's open as a touristic site. You just can go in the building and see it.
Ah, that's interesting. So it kind of it wobbles around.
Yes, it wobbles around. It's similar to the idea of tuning your guitar, or if you're thinking of a marble ball in a pocket, it would sway. Also, if you think of I'm not sure what they call it when the people skate over these wavy bits with the thing slide through.
I'm not entirely sure what that is.
And they have the same movement.
Yeah, so you're saying like
the skateboard thing?
So you're saying if they skate over sort of an undulating surface, but part of they sort of move to react to that?
Yes.
So like say their head doesn't move, but their feet move up and down?
Yes.
I get you.
So it's the same idea. So they're balanced, but they using the skate to do the cool movement and jump around holes. This is a similar idea because they keep their self-balance, and it's the same with the building because they get the pendulum movement to create a counter effect of the swaying.
So we can look up some videos later to share on Twitter and Instagram, I think. But you're reminding me all this talk of earthquakes and wind and things that make buildings fall down or destroy buildings in some ways, making me think of a different type of disaster. We like talking about movies a lot in this podcast and using those to explain the science. And you reminded me of the Stay Puft Marshmallow Man from the original Ghostbusters film, because he was obviously climbing up the side of that building. I think he stamped on the church at the bottom of that building. It was in New York, right?
Yes, I think it was filmed in New York.
Yeah, I think they had to climb up the stairs. You were talking about having the elevators. They had to climb the stairs, so I think it was the 22nd floor. The building itself, the bottom part of it, does exist in New York, because I walked past it. But apparently it doesn't have 22 floors. So the top part of the building was made up for the film.
Ah, so that was a ghost bit of the building.
Yeah, Spook Central, yeah. The ghostly building top.
That's spooky though, if you think of it. It was like it was a ghost movie and the building is a ghost.
It is. It's very, very meta, I suppose. But in the film, they also said the building was made out of some really weird materials that I don't think you'd find in a building, but you can tell me if I'm wrong. So it was made of a magnesium tungsten alloy and cold riveted girders with cores of pure selenium.
Well, the technical words are there, but I don't think any of the materials are real. We have girders in building, and we have bolts.
No, can you cold rivet something, or is that just a made-up phrase?
The rivet is similar to a bolt, so they would rivet something in or screw it in.
I guess you can rivet jeans, can't you? Just kind of fold a bit of the metal around, so it then gets wider than the hole it was put through. But I mean, it's a film, right? So all of that stuff could be made up. The whole thing was designed as a superconductive antenna to channel spiritual turbulence, I think.
Oh.
Doesn't sound like civil engineering.
Yeah, that's not my area. So turbulence is more with the aerospace engineering.
You've mentioned already steel and concrete are used as more traditional building material, not Spook Central stuff. Why do we use steel and concrete?
So steel is really very strong in tension and also in compression, but we mainly use it in tension because it's quite expensive. And concrete is really, really good in compression. So, and it's mainly when we build, we would think of reinforced concrete, which basically have a little bit of steel in it to reinforce it. So these two construction materials are giving you the enough strength for you to build high, because you achieve the foundation either by the bedrock or the piles, and you need a strong material for the body, and that's why we mainly use them, even though they do harm the environment. And I think there's lots of statistics says the construction industry contributes something about 11% of the carbon emissions as well. It's a lot. And it's mainly concrete and steel.
So we're talking about materials that have been around since the Industrial Revolution. I think you mentioned at the start. So they're quite old technology, and I kind of feel like it's no surprise that they produce a lot of CO2, because that seems to be a very industrial revolution kind of thing.
So I was saying it's just very unfortunate that we need to use such materials.
I mean, there'll be a lot of infrastructure required in the very near future to change how we do things. It's not quite tall buildings, building more wind turbines and things like that, or building more houses that are better insulated. So will have a lower carbon footprint or produce fewer CO2 emissions. But I mean, is that something that the construction or the civil engineering industry is trying to address as well?
Yeah, so we're trying to go back to using timber in building. Timber has been modified a lot, and now we have what we call this the engineered timber product. There's a lot of different ones. I'll give two examples that recently used in the tallest timber building, which is in Norway, which is it's used as hotel apartment now called the Wood Hotel. It's also called Voll Arkitekter. Homogeneous. I may have pronounced it wrong, so I apologize to all the Norwegian people for corrupting the name of the building.
Yeah.
This building is built using two of the very common now timber products, which called the CLT, which stands for cross-laminated timber. Is that when you get the lumber of the timber, cut it usually to boards, then you glue them perpendicularly to each other. So one layer would be one way and the other layer will go across it. And you'll do like 3 or 4 layers, which make it to be strong because you have tension, compression, changing as in layers. So that's the CLT. And the other one is you get the boards of the timber, glue them on the top of each other, and that's the glue lamp.
Okay.
They both have advantages and disadvantages, and they're much stronger than the normal timber in terms of some actions. And they use them now to build the tall timber building, which is an industry that is starting. The tallest timber building now, I think, is 85 meters high, the one in Norway.
Okay.
There is a couple in Canada as well.
So probably it would have been considered a skyscraper at some point. But I guess it depends what else is around it, right? If you consider that a skyscraper could just be something that is really prominent on the skyline, if everything else around it is quite short.
They can still claim they are the tallest timber building.
Yeah.
And it is really environmental friendly, the one in Norway, because they use the forest nearby to get the material and prepare the materials. And also like the advantage of timber when like one of the layers of that timber get corrupted, you just replace that layer. If it was a cross laminated timber, you just get the broken boards, glue something new and repaired.
Sounds like a very DIY type project.
Yeah, it seems to be very sustainable. That's what they're saying.
I live in quite a damp place. I live really close to the sea in West Cumbria. So with that sort of construction material, the treated timber, would I be able to use that, or would it just get really damp and rot?
They're treating timber for moisture. So they would cover the timber with certain chemicals that would get it not to rot. Yeah, that is something is growing as well. So I think even with the UK humid weather, timber building would survive. Also, there is something called, it's a hybrid between steel and timber. So they're doing a mix of the two instead of steel and concrete. So yeah, timber is getting a lot of attention at the moment.
I mean, concrete, I see that as just, well, I think we said in a previous episode, rocks that have been burned.
Yeah, it just lots of burning.
Yeah, and steel is kind of like rocks that have been purified and put together in some way because it's different metal ores, right?
But now like they're doing lots of recycling of the steel.
Yeah, I'd heard that there isn't yet enough steel in circulation to be able to keep on doing that indefinitely because we'll be building more infrastructure.
Well, that's true, but I don't know much about this. I won't comment.
Me neither. That's the limit of my knowledge on that topic. You mentioned elevators or lifts earlier on, and some of the hotels I've been in were so tall that going up in the lift, my ears popped, which is a bit disconcerting, but tall buildings do that to you, I suppose.
Yeah.
But I also imagine that there could be thousands of people in a building that big. We're talking, what, 20, 30, I don't know, even 40 stories big?
Yes.
So you could have, say 500,000, I don't know, that's probably a ridiculous number. So 500,000 people in a building that big. I do a bit of safety related stuff, and I always think, that's an awful lot of people to evacuate in some sort of disaster like a fire.
Yes, so
that sort of thing has to be considered.
Two things to think about there. The evacuation would divide the building to compartments, and these compartments need to have stairs going down. They mostly do internal stairs. Because the main thing with the fire in tall building, the fire travel on the external edge of the building. And that's why there's a huge regulation all about the cladding material you use to cover these buildings. Fire travel on the exterior side, even if it started somewhere interior. because it's easier to travel there than the inside.
Ah.
So you divide the building to compartments, and I think that's mainly why the elevator changes place, and you only get a high to a certain floor, then you change it.
All right, I'd never thought about that. That makes sense. And I just thought it was just some sort of design quirk that meant the elevator couldn't go all the way to the top.
Because you design the building a certain way that the elevator won't go to the top, or you attach something to it, but not necessarily in all of the tall buildings.
Ah, okay. So it's not just a case of we built it this tall, and now you wanted to build it taller, but we didn't necessarily think that through.
Yes.
Fair enough.
And when you start attaching buildings to its neighbors, it's also become a problem because you don't have the strength in the internal wall to have the same kind of services and providing lifts and elevators there. So I recently been in a hotel that it was basically they join two buildings and they have opening in between and they link them with the stairs, but the lift can go up to a certain point. And I think because the material of the other building was mostly all bricks, I think they could not fit the lift in. I was thinking that I don't have anything to prove it. And I think that's mostly why lots of the buildings in the UK don't have lifts in them or elevators.
Oh, maybe.
Because it needs a lot of strength to anchor it.
Brick was a very traditional construction material
Yes.
at one point.
Yeah, I think that's applied to most of the UK. Most of the UK don't have much lifts, and I was very disappointed when I moved. Like, there's no lifts.
You'll just have to improve that cardio and make use of those stairs.
What's with you with pushing me to use stuff? You want me to drive a manual and use my and now you're taking the lift away from me.
My secret is that I don't actually like technology for all my love of science and sitting on a podcast called Technically Speaking. I really Luddite.
I think we quite diverted the topic as we usually do.
We talked a bit at the start about skyscrapers and how they became more of a thing around the time of the Industrial Revolution, when steel and various other materials became, I guess, easier to make.
Yeah, and I think they needed some sort of a building that would be more densely populated because the cities were growing bigger and they were trying to save the space. So they went vertical.
If you've run out of space in 2 dimensions, go for a third.
Exactly. It's very popular in the US and in Japan mostly, though. Though in Japan they ran out of the space, so they need to go up.
When Japan's mostly mountains, although there's a lot of space, you might not be able to build something on it all that easily because it's quite steep.
But sometimes you want to work in that city because there is something happening there. There's some industry or companies or investment happening in that city, and that's why the city needs to expand.
Yeah, and then you have to think about your earthquakes again. If you've got that really tall building, we're back to talking about disasters and how to keep people safe. How do you make that building not fall down and crush people? Sorry, this is taking a weird turn.
We mentioned few of the method that we use today, but that were not historically available, and that's why some building did collapse in the history.
Yes, I guess older buildings wouldn't have had those the earthquake dampeners that you mentioned, the thing that oscillates on top.
Yeah, and also the external frame, it was not in the very first one. So if you have the tubular frame, which is basically externally stronger than the internal one, it was all the same strength.
So if we talk about skyscrapers, I guess to me, I mean, there are a few in the UK, and we used to live in Manchester, and there are a few really tall buildings that stand out really obviously as you're travelling in on the train. But for me, I think some of the most iconic tall buildings are probably in the United States, because you see them a lot in films.
Hollywood effect.
Yeah, I guess it was like that golden age of film, maybe, was around about the time people were starting to build these taller buildings as well.
Yeah.
You know, I'm thinking stuff like Godzilla and King Kong.
Yeah, these are very old, aren't they?
They are sort of 1950s, 1930s, but they stick in your mind when someone's talking about, it's usually a creature trying to climb up the side of something, or Ghostbusters.
Yeah, we definitely don't design building for a Kong attack, though.
But if you did, how would you go about doing that if you have a giant ape? Is there anything you could do?
I think it's using the external frame, and also with the same technology they have now with Burj Khalifa, because there's something else that they have a concrete column in the middle of the steel frame, which is the external, that kind of anchor everything in. And maybe put some wires on the building, the protection wires, what they call, the spiky ones.
Oh, you like to stop creature from actually grabbing onto the building to begin with.
Yes.
Like those spiky things they have on some buildings to stop pigeons from.
Some people have dusty glass as well. It just the glass one freaks me out though.
No, I suspect King Kong wouldn't have a problem with that. I reckon he's got pretty leathery hands and the glass wouldn't bother him. Or her, maybe.
Yeah, but I think anchoring the building really good in the middle with kind of like, even if you want to sway it one side, you have the strength to not to sway. And also I think trying to build with a flexible material that is kind of have a little bit of margin to sway. So even if it's swayed, it is not stiff, so it won't break.
Yeah.
But yeah, we definitely don't design for a King Kong attack.
See, I guess what's interesting about that from a historical point of view, so King Kong was sort of 1933, the film, and the Empire State Building was the tallest building at the time. But it's only 381 meters. I say only, are still quite tall. But there are much taller buildings now, right? You were talking about the Burj Khalifa building at the start.
Yes, it's about 800 meters. It's kind of double the Empire State.
Yeah. In some places, a mountain is defined as anything over 600 meters. So it's taller than mountain.
But they managed to climb it in Mission Impossible. Tom Cruise got in the top.
Was that the start of Ghost Protocol?
Yes.
Climbing up something made of glass with these sucker things, and then did one of them stop working?
Yeah. I'm not sure if that was intentional or it was really stopped working.
I assume it was a plot point.
Maybe.
To make you go right at the start of the film, oh my god, he might fall. That's what I thought anyway.
Well, they want to get the suspense to it, right?
Exactly, yeah. It would be a nice lead in, set you up for the rest of the film, I guess. Not that I can really remember the rest of the film, you know?
Yeah, I don't remember the rest of the film, but yeah, I really remember that scene. I think they made it stand out, and that's they kind of like the has the wow factor with the whole the tallest building and the climbing and everything.
Yeah. And so you were talking about maybe people will build taller ones.
Yeah, so I've been reading that people are trying to get about a mile high, which is double the height of the Burj Khalifa now, because it's about half a mile. I think with the technology we have now, I think it's doable. The other thing people are thinking about is the conditions of the workers, because you need lots of intensive work and you need to be very protective of the skilled worker you used as well to build these buildings. Because I know there were lots of issues with building Burj Khalifa, and there are lots of protests associated to it.
I feel like there's something about, trying to build a tall building where you probably shouldn't be, because you mentioned you had to figure out a way to do something about the fact it's on sand.
It's kind of like it started as a need and now it's a race.
The race for the tallest building to kind of show off.
Yeah, but I think they're not only iconic, it does hold a lot of people and it does provide lots of good services if you build them correctly.
You say build correctly, I guess that means they should last for a long time as well.
Yes, they need to be sustainable, because you don't want to build something that would collapse on people's heads.
Oh, I feel like we keep talking about these buildings that shouldn't be falling down, and we keep talking about trying to destroy them. I feel like maybe we should end it here in that case. Do you agree? Okay, right. I guess I'll sum up then. So I think I've learned quite a lot from Rwayda about how to build a tall building, and the foundations are the most important thing to think about. I guess you have to consider the location as well. What is classed as a tall building has changed a lot over time, comparing the Empire State Building to the Burj Khalifa. And you also need to think about the changing effects of the winds as you get higher up, and the materials that you use sound like they're very important, especially if you want to build something that is sustainable and will last and has a low carbon footprint from the outset, so will be good for climate change.
I'm about to throw a question here at the end as well. So if the climate is changing, what the changes we would need to make to buildings?
Oh, you mean if it gets really hot or really cold in the future?
Yes, and that would even change the wind pattern. Would the building we build now is safe for the future?
Oh, that is a very good question. Maybe we can explore that in a future episode. What do you think?
Well, sounds an intriguing idea.
It does. But we can end this episode here and maybe think about how we do a really speculative one about which buildings will fall down in the future. Oh dear.
We're very pessimistic today, but for a weird reason.
Don't you know what to say to that? If you want to carry on this pessimistic conversation, you can find us on Twitter. You can leave a comment on this episode. And we are now on Instagram, and we will put our Instagram details in the description for this episode. So thanks for sticking with us. We'll see you next time.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.